All right, what I'm going to do now is I'm going to go over the proof of the change of base formula, a very, very important formula when we're talking about logarithms, because not necessarily every calculator is going to have um, the option to plug in any logarithm with any base, and often you're really going to see only base 10 and base e, so the natural logarithm and just logarithm base 10. So this property is a very important one, and this is going to maybe help your understanding of where it's coming from and why it works. So let's go ahead and just talk about the change of base formula. Okay, change of base formula. Okay, and at some point in my class, you are going to need to know this one. So if I take a logarithm, let's say it's base a of x. Okay, so if I take a logarithm with base a of x, really what I can do is I can take a logarithm of any base. Let's call it base b. So this can be any base you want. Often for our use, you're going to see base 10, but we're doing a proof and we can't just use base 10 because we want it to work for any generic base, but it will work for any generic base, x, and then we can divide it by the logarithm base b of a. So if you look here, you can take a logarithm any base you want of x divided by logarithm base b of a, and you divide these two and it's going to be equal to each other. So this is going to help us use the calculator to solve some of our logarithms. Okay, so let's just go ahead and take a general logarithm. Let's go ahead and take that original logarithm. Logarithm base a of x, and let's just say it's equal to some number y. Okay, so if it's equal to some number y, that means I can rewrite my logarithm and say if I take a to the y power, that's going to be equal to x. And that's really the whole point of logarithms, is they help you find exponents, or like if you're given a base and what it's equal to, it's going to help you find that exponent. Okay, so let's just take logarithm base b of each side. And so if I take logarithm base b of a to the y power, I will also take logarithm base b of x. Okay, and so you can basically take a logarithm of any base to each side and it remains that same equality, just like if you were to add or multiply each side by a variable. Okay, now the product property, which there's a proof on the product property already on this page right before this one, tells me that if I take logarithm base b of a to the y power, I can actually pull this y power out and multiply it in the front. So y times logarithm base b of a is equal to the logarithm base b of x. And you know, even though there's a lot of letters going on here, logarithm base b of a, you know, if we knew what these numbers, this would just be a number here. Same with this. So if I want to get the y by itself, I mean, I think that's just what I would like to do. I think I am going to go ahead and just divide by logarithm base b of a. Okay. And so that means y is equal to a logarithm of any base, we'll call it b, of x, divided by logarithm of any base b of a. Okay, and this is incredibly powerful because we actually know what y is equal to. Y is equal to the logarithm of base a of x. And right here, this line here has proven to you all that the logarithm change of base formula indeed works. And it works just by using the properties that we already know and have of logarithms.